So now I'm writing question 6. That's the one we are doing now. Let's quickly focus. It says, if a ball is thrown into the air with a velocity of 12 meters per second. So just put it, V is 12 meters per second. It's important. Its height in meters after t seconds is this. So height, we have y is equal to 12t minus 4.9t squared. Then they said, find the velocity and acceleration. So if a ball is thrown into the air with so this is the initial velocity, the u. Now they said here, so this is the initial velocity, 12 meters per second. And here they're saying its height after t seconds is this. Find the velocity and acceleration when t is equal to 2 seconds. So anyway, let's find that. Let's find the velocity and acceleration when we have time at 2 seconds. So how do we find that? This is the height. And to find the velocity, we differentiate once. So you can say velocity is equal to dy dt. Okay, so that is what it is. First, let's find dy dt. Let's find it. We can find dy dt or we can say y prime. It's like y prime is still dy dt. Let's differentiate. What is y prime? We differentiate 12t is 12, then minus 4.9t squared. 2 comes down, 4.9 by 2. So you say 4.9 times 2. Is it like a 9.8? Yeah, 9.8. 9.8. Then the power reduces by 1. It's t, 9.8t. Then we can say now y prime prime is the second derivative. We differentiate 12, it becomes a 0 minus 9.8t. If we differentiate with respect to t, we just get 9.8. Okay. Now you can say velocity is equal to y prime, okay, which is equal to 12 minus 9.8t. Okay, so here you can say at t equal to 2, you can now say y prime will be equal to, you can just say, maybe let's just start by doing that. Okay, we can say at t equal to 2, that means now we can put our y prime. What is it going to be? Y prime will be now 12 minus 9.8 of t, which is 2, which is going to be 12 minus, here we say, what is 9.8 times 2? It's 19.6. So 12 minus 19.6, and that is negative 7.6 meters per second. This comes out as the velocity, which means this thing is now coming back down. Okay, this thing is now coming back down. And now we can say, so you can say, therefore, velocity when t equal to 2 is negative 7.6 meters per second. Okay, or you can say therefore when t equal to 2 seconds, velocity v is equal to negative 7.6 meters per second. Then now you can say we can say when t equal to 2, y prime prime will be equal to negative 9.8. You can say therefore when t equal to 2, acceleration, which is like a g, this is negative 9.8. You can say a, rather. A is negative 9.8, but it's meters per second squared. Okay, meters per second squared. Because acceleration is the second derivative, velocity is the first. So you have the height, then this first derivative is going to be velocity. Okay, this is going to be velocity function. Then here is the acceleration function. Okay, the acceleration function. This is how you get acceleration, the second derivative. This is the velocity function. Then here is the height function. So these are functions. In other words, they will give you the answer when you tell them how much time has gone. So you can say at t, when t is now 5, when t is whatever. That is why we mean by function. It's not an answer, but it's a function. It's a machine which can produce answers for it when you tell at the time. So for here, acceleration is a constant, yes, and you can see that this thing now, the reason why we have this acceleration being negative, when acceleration is, we'll be just dealing with it as because of gravity. So now we'll be saying Yes, acceleration should always be, I don't know if you remember from physics 101, that it's negative. Now, the thing of it is, you say to me, what about this 12? Wasn't the 12 meters per second that we were given here, wasn't it supposed to work somewhere, this 12? It is already working. That's why you see it inside here, the function. So don't think it has been neglected. No, that is why we have it there. Okay? That is what it is. These are the solutions, and you are done.